We are going to talk about the 3 rules of algebra. Rules of algebra. And this is how you solve algebra problems. So these are obviously really important. And technically there's 2 rules and 1 guide on how to solve it. So the rules are, number 1, always do the same thing to both sides. Now you might say both sides of what? Well, it's technically both sides of the equal sign, but we always say always do the same thing to both sides. And number 2 is only one equal sign per line. Only one equal sign per line. If it has less than 1 equal sign or has more than 1 equal sign, you are not doing algebra. And then the 3rd rule, which is really just a guide, is undo what is happening to the variable. So you're going to undo it. You're going to do the opposite of what's happening. If it's being multiplied by something, you're going to divide by that. If it's adding, then you're going to subtract. Same basic thing. And that's always going to be true. So if you follow those rules, then you'll be able to solve algebra. Always same thing to both sides. Only 1 equals per line. Undo what's happening to the variable. Now, one of the things you need to understand when solving algebra is we really don't care that you can figure out what the value of x is. If I say x plus 3 equals 10, I would hope that every one of you could tell me right off the bat that x equals 7. I don't care that you know that x equals 7. Well, I care a little bit. But really what I care about is, do you know how to show the steps to get to x equals 7? I know you can do it in your head, but you have to show the steps. And every single algebra teacher will tell you that algebra is not about the answer, but it's about the steps. And that you must show every algebra step, or you will not receive any credit. Sometimes I give 9 points for the steps and 1 point for the actual answer. But let's take a look at the simplest of problems. Let's take a look at that problem. X plus 3 equals 10. So first we identify what's the variable. Oh, our variable is x. And what's happening to our variable? We are adding 3 to our variable. And what is the opposite of adding 3? It's subtracting 3. So we're going to subtract 3. Now, if I subtract 3 from the left side, I also must subtract 3 from the right side. So if I subtract 3 from the left side, I must subtract 3 from the right side. And then this undoes this. Poof, that goes away and leaves me with just that x. Do you see that plus 3 and the minus 3 gives me just x? And it's not that we really are subtracting 3, we're really undoing the plus 3. I want you to get that in your mind, that we're undoing the plus 3. Because we undo the plus 3, that makes it go away. We're left with whatever's left, in this case just x. And then 10 minus 3 is 7. Now notice I have only 1 equal sign per line. I try to line up my equal signs, kind of like we line up decimals, and I get x equals 7. This is showing all my work. I've shown that I've undone what's happened to the variable. I've shown that those went away, poof, and I show what my last answer is, and there's only 1 equal sign per line. Let's look at another example. Helps if I actually have a pen. 7 equals x plus 2. So our variable's name is x. What's happening to x? is that we are adding 2. The inverse of adding 2, or the opposite of adding 2, is subtracting 2. So we undo the plus 2 with a minus 2, put a line to go poof, that leaves us with just x, and then 7 minus 2 is 5. And so the answer is 5 equals x. If you wish, after you get the 5 equals x, then you can say x equals 5, because many people like the variable to come first. Check with your teacher to see which way they want it. Let's look at another example. X minus 3 equals 4. Well, now we have a minus 3. X is getting 3 taken away from it. The inverse of that is adding 3. We do the same thing to both sides. Those go poof. We get x equals 4 plus 3, which is 7. And we show our work this way. Let's look at another example. Let's go really hard here and go x plus negative 4 equals negative 2. Well, the inverse of adding negative 4 is taking away a negative 4. Taking away a negative 4. This goes poof. X equals, now this is a little bit harder of a problem, so you might want to rewrite it like that and say, oh, I can do this as an addition problem. And now I see that x equals, well, those are different signs, so I take the difference between 2 and 4, which is 2, and then a sign of the larger number, which is positive. So the answer is x equals positive 2. And we do these all the same way. So negative 3 equals x minus 5. X is our variable, and we add 5 to undo the minus 5. We get x equals negative 3 plus 5 is 2. So x equals 2. Notice we do want to have it say 2 equals x, because negative 3 plus 5 is equal to 2. Negative 3 plus 5 doesn't give us x immediately. Negative 3 plus 5 gives us 2. And then this negative 5 undone with plus 5 gives us x. And so we have to write 2 equals x, and then we can flip it around. Now, I want you to know that x is most common our variable, but we can have anything we want as our variable. We can have q plus 7 equals 3. We subtract 7 from both sides. Poof, we get q equals 3 minus 7 is negative 4. So q equals negative 4. We can have any variable we want.